The next question in this series is finding the inverse of a matrix. So the question is, find the inverse of the following matrix. Now, inverse of a matrix is given by the following definition. So, inverse of A is denoted as follows: A inverse. This is 1 over determinant of A times the adjoint of A. So, this is how we find the inverse of a matrix. Now, in inverse, the property is that A times A inverse is A inverse times A, which is equal to the identity matrix. So this is the relation which defines the inverse, and then this is how we actually find the inverse of a matrix. Now we see that the inverse can be found only when the determinant is non-zero. The determinant of an n cross n matrix, so if A is an n cross n matrix, if A is an n cross n matrix, I going from 1 to n, j going from 1 to n, then the determinant can be written in terms of the Levi-Civita symbol as follows. Where we have used the Einstein's summation notation, and epsilon is the Levi-Civita symbol, or also known as the alternating symbol or the antisymmetric symbol. Now adjoint of A is the transpose of the cofactor matrix. C is the cofactor matrix, and the cofactor matrix in turn is written as follows. Where this M is the matrix of minors, and this minor is obtained as follows. So this minor is basically determinant of the submatrix formed by deleting the ith row and jth column. So these are the definitions used to find the inverse of a matrix. Let us now apply it to this question that we have, then things will become much more clear. So this is our given matrix, we need to find the inverse of it. So let us solve it. So we are given A is as follows. So determinant of this matrix would be given as follows. So we will focus on the top row. Then we will take each element of the top row and multiply it with the determinant obtained of the submatrix by deleting that row and column. So let me show it over here. So determinant A would be first element right here is 0. So 0 times if we delete this row and this row, this row and this column, then we are left with this 2 cross 2 1 0 0 0 matrix, and the determinant of this is going to be not 1, let me change the color, is going to be 1 into 0 minus 0 into 0. Now we are focusing on this element, the next element, but this will come with a negative sign because of the Levi-Civita alternating symbol. So the coefficient of this element was ij is 1 1, and for this it is ij is 1 2. So this gives minus 1 to the power 1 plus 2, that is going to give us finally minus 1. So this one comes with a negative sign. So minus 0 times, again we will delete this row and this column. So this is the remaining matrix. Determinant of this is and finally we will look at this last element right here, and this will come with a plus sign, and then again delete this row, this column. This leaves us with this 2 cross 2 matrix. So determinant of this would be as follows. So this gives us the determinant of A to be negative 1, which is clearly not equal to 0. So we can find the inverse of this matrix. Now we need to find the adjoint of this matrix. So adjoint is nothing but transpose of cofactor matrix. So let us first write down the cofactor matrix. So cofactor matrix would be found as follows. So again, for the first element right here, we will delete this row and this column. So determinant of this right here is 0. So our first element would be 0. Then for the next element, we will have minus 1 times, because this is minus 1 raised to the power I plus j. For this element, I plus j is 1 plus 2, which is 3. So minus 1 to the power 3 is minus 1. So we have this negative sign. And then we will delete this row and this column. So the determinant of this part is also 0. Next we will delete this. So determinant of this one and this one will come with a plus sign, is -1. Similarly, we will do for the other elements as well. So now focusing on this element, we'll delete this column and this row. So this gives us determinant of 0. And then this one has determinant of -1, and here we will have 0. Then again determinant of -1, and like so. So this, let me rewrite. This is the cofactor matrix. So adjoint is transpose of cofactor, which happens to be the same matrix as the cofactor. This is self-adjoint. So this is the adjoint. Now inverse is 1 over determinant times the adjoint. So this is 1 over determinant is -1. So this gives us the following as the inverse. So this is the desired solution. This is the inverse of the matrix that we were supposed to find. So this is how we find the inverse of any matrix, provided that the determinant of the matrix is non-zero. If the determinant is 0, then we cannot find the inverse of that particular matrix. And as a check, we can find out this. We can do A times A inverse, and we will see that this indeed is the identity. So this is A times A inverse. So we see that A inverse is A in our case, in this case, this particular case that we have. So this indeed gives us the identity matrix. This is identity. So the inverse that we have found out is indeed the correct inverse. So this solves the question, a simple question based on how to find the inverse of a matrix.